What is non-zero digit? A digit which has a definite value in the number system. Power of 10 is always irrelevant to identify significant digit in a given number. All zeros between non-zero digit are significant, no matter where the decimal point lies. If the succeeding term is greater than 5, the preceding term will be raised by +1. Hello everyone, I am Nishma Nanjamma, Faculty of Physics in Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Once again, welcome back to Session 4 on Chapter 2, Units and Measurements. I'll teach you what is significant figures, how do you round up the significant figures, what are the rules to be followed in significant figures, and I'll be teaching all these topics in my Session 4 of Units and Measurement, and we'll solve few problems, few numericals related to the significant figures in today's session. So let's begin today's session. So first let's start. What do you mean by significant figures? What does the term significance mean? It means important. So it is a significant digit or significant figure. We can call it a significant digit or significant figure. Significance means importance. So let us first read the definition significant figures. The results obtained due to the measurements includes digits known as reliably and to the first digit that is uncertain, which are known as significant digit or significant figures. Try to understand. I'll repeat the definition. I'll repeat the sentence. The results obtained due to the measurements includes digits known as reliably and the first digit that is uncertain, which are known as significant digit or significant figures. So I can say reliably and uncertain will give reliably plus uncertain gives me my significant figure. Significant figure. So reliably plus uncertain give rise to significant figures. So carefully analyze and understand what do you mean by significant figures. So significant figures, for example, I am performing a measurement. So everything starts with measurements, units and measurement. I am performing a measurement. The time period for oscillation of simple pendulum. So the time period for oscillation of simple pendulum is given as 1.62 seconds. So I know what is the time period for calculation, the time period for oscillation of simple pendulum. It is 1.62 seconds. These are the digits, right? These are my significant numbers or significant digits or significant figures. So how many significant figures you have in this time period? It is significant figure S is equal to 3. I have 3 numbers 1, 2, 3. I have 3 numbers 1.62. Here 1.6 are reliable and certain. My last digit is uncertain. My last digit is uncertain. So reliable plus uncertain gives you significant figures. For example, take another measurement. I am measuring what is the weight of an object. What is the weight of this pen? What is the weight of this pen? For example, I'll write it as 1.23 kg or something like this. You can see the weight of the object given it is 2.87.5 kg. Written 1.23. So, how many significant figures I have here? 1, 2, 3. So, totally 3 significant figures I have, wherein 1 and 2 are reliable and certain. 3 is uncertain. Reliable plus uncertain gives me significant figure, which is 3 here. You can see 287.5 kg is the weight of the object. It has 4 significant figures. 1, 2, 3, 4. 4 significant figures, and that is 287. 287 are certain and reliable, while the last digit 5 is uncertain. So reliable digits and uncertain digit overall is my significant figures. So the result obtained to the measurement, weight of the object is a measurement. 287.5 kg is my result. So the result obtained due to the measurement, it includes digits known as reliably and the first digit that is uncertain. The 5 is here uncertain, which are known as significant digit. Overall it is known as significant digit or significant figures. So what are the rules for the significant figures? There are 7 rules. When you go through these 7 rules, you can understand clearly what do you mean by significant figures. So don't break your head. What is significant figures? Significant. It is important. So in the previous sessions in unit and measurement, in all the numericals, whenever we get numerical value, maybe for the weight of the object or weight of the, what is the time period for the pendulum, all this, when we get a final result, we always round up. We always round up the digit in the last, round up the digit of the last term. What is this rounding up? We'll learn in this session. Once you go through the rules and how you round up the digit, you can clearly get an idea what is significant figures. So next, rules to be followed in determining significant figures. So here even the significant figures has a rule, certain set of rules to be followed. So we'll start from rule 1. So what is a rule 1? All non-zero digits are significant. What do you mean by this? All non-zero digits are significant. What is this non-zero digit? What do you mean by non-zero? So non-zero digits are nothing but a digit which has definite value in the number system. A digit which has a definite value in the number system is known as non-zero digit. For example, 1, 2, 3, 4, all these are non-zero which has a definite value in the number system. So all non-zero digits are significant. Then what about 0? 0 don't have any significance? We'll study that here. So rule 1, to understand it much clear, much better. So all non-zero digits are significant. You can see here the numbers, all are non-zero. Can you see any zero term coming, zero number coming here? All 4, 2, 3, 1, 4, 8, all these has a definite value in the number system. So there are 1, 2, 3, 4, 5, 6. 6 significant figures. For example, consider the weight of an object, weight of a stone. For example, it is some 4.831 kg. Example, approximation. Weight of some object is 44.831 kg. So, even though you have decimal point or you don't have decimal point, these are the non-zero digits. So, how many significant figures you have here? 1, 2, 3, 4, 5. So, you have 5 significant figures. Similarly, you have 1, 6, 7, 8, 9. So, how many significant digits you have here? 1, 2, 3, 4, 5. So, you have 5 significant figures. You can see you have 5 significant figures. So, all non-zero digits are significant. You have 5 significant figures, 44.831 kg. So, all these are non-zero digits which has a definite value in the number system, and if you count, you have 5 significant figures. 5 significant figures. That is rule 1. Keep in mind, all non-zero digits are significant. All these rules are important for you when you solve the numericals, when you round up the digits in significant figures. So, the second rule, what does my second rule tell me about? All zeros between non-zero digit are significant, no matter where the decimal point lies. So, rule 1 is only about non-zero digit. Rule 2, now my 0 has some significance. In first rule, 0 didn't have any significance. It was insignificant. So, in rule 2, my 0 is getting some significance. So, let us try to understand what is it. All zeros between non-zero digit. For example, you have 101. 0 between non-zero digit. 1 is what? It's non-zero. It has a definite value in the number system. 1, 2, 3, etc. So 0 between the non-zero digit are significant, no matter where the decimal point lies. Whether you have decimal point here or you have decimal point here, it doesn't matter. 0 coming between two non-zero digit has significance. It is significant. So you can see here example 209.007 contains 6 significant figures. 1, 2, 3, 4, 5, 6. It has 6 significant figures. So 0 is coming between two non-zero digit and 0, 0 is coming between two non-zero digit. Wherever might be the point, it might be here or decimal point might be here. Wherever the decimal point is, the 0 coming between two non-zero digit is significant. For example, consider I have 102.001.01. You can see so many zeros coming here. So my 0 has value, has significance in rule 2. What does it say? 0 between two non-zero digit. 1 and 2 are non-zero digit. 2 and 1 are non-zero digit. Again 1 and 1 are non-zero digit. What is non-zero digit? A digit which has a definite value in the number system. Example 1, 2, 3, 4, 5, 6. It can be anything which has a definite value. So 0 is coming between two non-zero digit, and even the point is here. The decimal point might be here, or you have the decimal point here, or you have the decimal point here. That doesn't matter. So decimal point doesn't matter in rule 2. All that matters is 0 should be between two non-zero digit. If 0 is between two non-zero digit, then it is significant, no matter where the decimal point is. So it has 1, 2, 3, 4, 5, 6, 7, 8. It has 8 significant digits or significant figures. Next is rule 3. Keep in mind what rule 1 is. All non-zero digits are significant. What is rule 2? All zeros between two non-zero digits are significant. So 0 has some significance in rule 2 wherever the decimal point is. What is the third rule? If the number is less than 1, so we are talking about the number less than 1. If number is less than 1, to the left of the first non-zero digit are not significant. So you can see example here. If number less than 1, that means 0 is less than 1, right? 0 is to the right of the decimal point, and the first left non-zero digit are insignificant. The underlined zeros are not significant. So you have 1, 2, 3, 4. You have 4 significant figures here. So analyze. I'll take one more example. 0.000. 0 to the right of the decimal point to the first left non-zero digit. 1, 2, 0, 3, 1. So this is my digit where 0 to the right of the decimal point and the left of the first non-zero digit are insignificant. It is insignificant. 0 is less than 1 and these zeros are insignificant. Then what about this 0, ma'am? What about this 0? This 0, it is significant. Why? My rule 2 says that 0 between non-zero digits are significant. The zeros between the non-zero digit, 2 and 3 are non-zero digit. Zeros between the non-zero digit are significant. Hence, I have 1, 2, 3, 4, 5. 5 significant figures here. So, less than 1. 0 is less than 1. The number less than 1 to the left of the first non-zero digit. So, this is the first non-zero digit which I am getting after zeros. So, zeros to the left of non-zero digit are not significant. For example, if I consider 0.0100203, you can see here zeros to the right of the decimal point and this is my first non-zero digit. First non-zero digit are not significant and these zeros are significant. Why? Because rule 2 says that the zeros between the non-zero digits are significant. Hence, this is not included. It is insignificant. And 1, 2, 3, 4, 5. I have 5 significant figures. That is rule 3. Keep in mind, it is rule 3. Zeros to the right of the decimal point and the first left non-zero digit. So, zeros are continuing and it will stop where it has, zeros has a stop. Where it has a stop? To the first non-zero digit. You have 0.00000 zeros to the right of the decimal point, and I am considering 203 here. Zeros to the right of the decimal point and the first left non-zero digit has no significance, and 0 after this non-zero digit has significance. That is for my rule 2. So, next, the fourth rule. What is the fourth rule? The terminal or trailing zero in the number without a decimal point are not significant. The trailing or terminal zero. What is terminal zero? Trailing or terminal zero. Terminal in following zeros here. Zeros in the number without the decimal point are not significant. So, you can see decimal point, the significance of decimal point here. So, my decimal point has got some significance in rule 4. So, the trailing zero, take the example 1, 2, 3, 0, 0, 0 has 3 significant figures. It has only 1, 2, 3 significant figures, the trailing zero being insignificant. So, the zeros without the decimal point, the zeros following 1, 2, 3, the trailing zeros, that is what 3 zeros here has no decimal point in between. If it was 123.000, then it would have been 6 significant digits. But the following 0, 1, 2, 3 followed by 3 zeros has no significance because there is no decimal point. So, there is only 3 significant figures. Another example, consider 10,000. A non-zero digit 1. 1 is a non-zero digit. A non-zero digit followed by 4 zeros. A non-zero digit followed by 4 zeros. So, that is my trailing zeros. There is no any decimal point in this 10,000. So, read the rule. Trailing zeros in a number without decimal point are not significant. So, these zeros are not significant. I have significant figure 1. Trailing zero means 10,000. Non-zero digit 1 is followed by 4 zeros. Trailing zeros, they don't have any decimal point in between. So, they are not significant. Only it has one significant figure. If I had a point, ma'am, then what is the case? If there was a point, if decimal point had importance, then it would have been 5 significant figure. We study that in the next rule. Fifth rule, see. Fourth rule, if decimal point is not there, then the zero has no significance. The fifth rule, trailing zero in a number with the decimal point are significant. In rule 4, what was about decimal point? A trailing zero in number without a decimal point are not significant. But in rule 5, a trailing zero in a number with the decimal point are significant. If there is no decimal point, then 0 has no significance in rule 4. In rule 5, the 0 has significance if there is a decimal point. So, it is just a reverse of rule 4. Keep in mind, the numbers are 3.500 or 0.06900 have 4 significant digits. How, ma'am? It is 4 significant digits. If you take 3.500, this 3.5 is followed by 2 0. These 2 0 is considered as 4 significant figures. How? Because there is a decimal point coming. If it was 3500 without a decimal point, then 0 has no significance because there is no decimal point. Then S would have been 2. Significant figure would have been 2. But since there is a point in between 3 and 5, between 2 non-zero digits, so 0 following the 5 has significance. So, S is equal to 4. Look at this one, 0.06900. There is a decimal point between 0, but there are 1, 2, 3, 4, 5, 6 digits. But you are telling that has only 4 significant figures. How is that? That is why I said you all the rules should be in your mind when you study significant figures. Remember rule 3. What does my rule 3 says? Number less than 1, write to decimal point and the first left non-zero digit. The first left non-zero digit here is 6. So these are insignificant. Hence I have only 4 significant figures here. 4 significant figures here. So remember rule 3. What does my rule 3 says? 0, number less than 1. Here it is 0, less than 1. Number less than 1 to the right of the decimal point and to the first left non-zero digit are insignificant. Even though you have decimal point, but my rule 3 will be violated if I tell there is 6 significant digit. Rule 3, it is insignificant, so you have 4 significant figures. So these zeros, 6,900, consider 6,900. If it was 6,900 without a decimal point, then zeros are insignificant. It was only 2 significant figures. Since there is a point here, the zeros which are following 9, the trailing zeros has significance. That is why it is 4 significant figures. So, sixth rule, the unit of quantity. What is unit? Temperature is represented by Kelvin, or amount of substance is given by mole, length is given by meter. All these meter, centimeter, these are the units of length. Mass is kg, mass is given by kg, temperature is given by Kelvin. All these are the units. So the unit of the quantity is changed from one system to another. Say I have length, unit of length is meter. So it is changed from one system to another, means length in meter is changed to centimeter. So unit of quantity, length is a physical quantity which has a unit meter. So unit of quantity is changed from meter to centimeter. For example, from one system to another, the number of significant digit still remains the same. What do you mean by this? Consider the length of the rod which I have calculated is 2.467 centimeter. So from one system, from centimeter, I am converting it to the meter. So when I convert it into meter, what it will be? Centimeter is 10 to the power minus 2. So then meter will give me 0.02467. It is 0.0467 meter. Centimeter is 10 to the power minus 2. So when I convert, it will be 0.02. I have added 2 zeros. 0.02467 meter. Now I have converted a physical quantity length from one system to another system. So the number of significant digits still remains same. How many digits did you have here? 1, 2, 3, 4. So significant digit was 4. So what is my significant digit here after converting from centimeter to meter? 1, 2, 3, 4, 5, 6. Whether it is 6? If it is 6, then you are wrong. Why? Because it is 4. S is 4. Once again I tell you, be careful, because my rule 3 says that a number less than 1 to the right of the decimal point and to the first non-zero digit is insignificant. That is why it is 2467. S significant figure is 4. When you deal with rule 4 or rule 5 or rule 6, don't just think only the numbers. Remember all the rules. What does it say? Then only you are able to calculate what are the significant figures in this length measurement. Even you convert from centimeter to meter, convert the physical quantity from one system to another system. But still, if you convert from centimeter to meter, you can see 2 zeros coming up. So even the first length, centimeter, has 4 significant figures. Similarly, even though you have 2 zeros, from rule 3 we know that these are insignificant. That's why there are again 4 significant figures. Both has 4. So significant digits still remain the same even though you convert from one system to another system. That is rule 6. What is my rule 7? Last rule in the significant figure is rule 7, which talk about the power. The power of 10 is always irrelevant. The power of 10, the power of 10, something to the power of 10 is always irrelevant to identify significant digit in a given number. For example, what is, see here, velocity of light. It is given as 2.997 into 10 to the power 8 meter per second. In vacuum, velocity of light is 2.997, which is written as 3 into 10 to the power 8. How did I round up this 2.997 to 3? What is this rounding up this digit to 3? This we'll study in the next slide, in the upcoming slide. So it is 3 into 10 to the power 8. Consider this one. Consider this one. Something this power of 10, 10 power 8. Power of 10 is irrelevant for me to write my significant digit. It is irrelevant for me to write my significant figures. So it has only 4 significant figures. It has 4 significant figures. Consider what is the mass. Consider the mass is equal to 9.109 into 10 to the power minus 30 kg. Mass is given as 9.109 into 10 to the power minus 30 kg. Power of 10, 10 to the power minus 30. It is irrelevant for me to write my significant numbers or significant digit in the given number. So, I know my significant figure is 1, 2, 3, 4 again. S is equal to 4. So, this power of something, it is irrelevant for me to write my significant figures in the given number, given mass or given velocity of light or whatever it is, given value, that it has a power of something. If that power is there, it is irrelevant for me to write my significant figures. So, apart from that, the number is 4 and significant figure number is 4 here. So, these are the 7 rules. So, these are the 7 rules followed in the significant figures when you study, when you write the significant figures. You have rules for arithmetic operations with significant figures. Arithmetic operation, mathematical operation, that is multiplication, division, subtraction, addition. When you do all these things, there is rules for which you have to follow with significant figures. So, what is my rule 1? In multiplication or in division, the final result must retain as many significant figures as are there in the original number with least significant figures. Either you divide or you multiply the physical quantities, the final result must retain as many significant figures as are there in the original number with least significant figures. Let us try to understand with this with much clear with the example. Example 1. The mass of the object is 4.327 gram. It's in gram. And the volume is 2.51 centimeter cube. Find the density of the object. So, final result must retain as many significant figures as are there in the original number with least significant figures. So, the mass of object has 4 significant figures. 1, 2, 3, 4. 4 significant figures. When you write significant figures, keep the rules in your mind. So, there are 4 significant figures. Volume has 3 significant figures. Which has the least significant figures now? It is volume, right? So, the result which you get at final should have least significant figures. The volume has least significant figures. How do you calculate density now? Mass of the object is given, volume is given. How will you calculate density? Density is given by mass by volume. Ratio of mass to the volume. So, mass by volume. What is mass? 4.327 gram. What is volume? 2.51 centimeter cube. So, what is the value you get here? It is 1.6912 some centimeter cube. You will have still more digit 1.612. For example, 1.6912. When you calculate, you will get this value. So, what is the rule says? So, the significant figures as are there in the original number with least significant figures. For mass and volume, which has the least significant figures? M has 4 significant figures. Volume has 3 significant figures. Which has the least significant figures among these original values? It is volume has 3. So, your result at the end, that is the density, should also have 3 significant figures. It should be rounded off to 3. So, I will write 1.69. Why it is 1.69 is because you learn this in rounding off. When this digit 1, it is less than 5, that is, it is not equal to 5. So, we will drop this digit and write 1.69. When you divide this mass by volume, your value will be 1.612 into something. So, since the rule says it should be the original number with least significant figures, the value of density which you get should be with least significant number. That is, 3 has volume has least significant number. So, I will round it off into 1.69 gram per centimeter cube. So, this is the rule for significant figure in case of multiplication or division. Rule to be followed for arithmetic operation with significant figures. You understood? Either you divide or you multiply. The final result which you get, the final result must retain as many significant figures as are there in the original number with least significant figures. So, the final result should have the least significant figure among mass and volume. Mass has 4, volume has 3. Which has least significant figure? It is volume, right? So, your answer should retain 3 significant figures at the last. How did I round up this digit? We learn in the upcoming slide. Now, the rules for arithmetic operation with significant figures. When you have addition and subtraction, what is the rule you follow for significant figures? Multiplication and division you got to know. You should write the least significant figure that you have among the two original value. The mass density value should have the least significant value. So, in addition or subtraction, the final result should retain as many decimal places. Now, it is decimal places, not least significant figures. So, should retain as many decimal places as are there in the number with least decimal places. Try to understand. The previous multiplication and division, what we wanted least significant figures. So, here we are considering decimal point. So, I want the least decimal places. Let us try to understand this with an example. I have two resistors, R1, R2. 100.13 ohm, I said you the previous session, the unit for SI unit for resistance is ohm. I have two resistors of resistance 100.13 ohm, 200.107 ohm are connected in series. I know the formula for series is R1 plus R2. RS is equal to R1 series. RS is equal to R1 plus R2. Calculate the effective resistance. Calculate the effective resistance. So, R1, it is 100.13 ohm. R2, it is 200.107 ohm. So, which number has the least decimal place? It is R1. You can see 0.13, it has least decimal point compared to R2. R2, after point you have 3 digit, after point you have 2 digit. So, R1 has least decimal places. So, when you calculate series, formula is R1 plus R2. Add R1 and R2, you will get 300.237 into some ohm. So, you can see it is 300.237 ohm. But my rule says the result should retain as many decimal places are there in the number with the least decimal places. So, R1 has least decimal places. So, I will write it as 0. Answer at the final, after the calculation of effective resistance, the final answer should have least decimal point. Here R1 has least decimal point compared to R2. So, I am rounding up my answer to least decimal point. So, in multiplication and division, we should consider least number of significant figure. If mass and volume is given, which has least significant figures? Here we consider R1 and R2, two resistors. Which has the least decimal places? Least decimal places, R1. So, my answer should have least decimal places. So, that is the rule to be followed in addition or subtraction. So, next, Round off to 3 significant figures. I have asked you a question. Round off to 3 significant figures. Now, how will you round off the figures? 2.746 is given. What is the rules you follow to round off? 2.746. Here, this is the preceding term. This is the preceding term and this is the succeeding term. Preceding term and succeeding term. If the succeeding term is greater than 5, if it is greater than 5, 6 is greater than 5. So, what happens now? 6 is greater than 5. So, my preceding term will be raised by plus 1. That is 4 plus 1, it is 2.75. 2.75. If the succeeding term is greater than 5, the preceding term will be raised by plus 1. So, it is 2.75. What in the second case? 2.743. This is not equal to 5 or greater than 5. So, the 3 is not equal to 5, or greater than 5. So, what happens? We will drop term 3. So, it will be 2.74. 2.74. What in case of third question? You have 2.745. So, it is equal to 5. If it was greater than 5, so preceding term will be raised by 1. So, plus 1 will be added for your preceding term. It will be 2.75 or you have 2.788. So, your succeeding term is greater than 5. So, my answer will be 2.79. 8 plus 1 because 8 is greater than 5. So, here it is 2.743. 3 is not equal to or greater than 5. So, we will simply leave this term. It will be 2.74 in case you have 2.742. So, it is not equal to or greater than 5. So, I will drop term 2. I will have only 2.74. In case if it is equal to 5. So, what happens? 2.745. If it is equal to 5, the preceding term, if it is even, we will drop down the 5. It will only be 2.74. That's all. If it is, consider if it is 2.735. 735 instead of 4, I have an odd term in the preceding term. Preceding term is odd. Now it is equal to 5. It is, if it was 6 or 7, then I would have added 1 plus 4. But here it is equal to 5. If it is odd, you will add plus 1 to odd, 2.74. So, when it is equal to 5, when your succeeding term is equal to 5, then the previous term, that the preceding term is even, then we will drop the 5. It will be only 2.74. If it is 2.725, then 25, then what is 5 here? 5, it is equal to 5. So, the previous term is even. So, I will drop 5. I will leave 5 as it is. So, 2.72 is my answer. In case I have 2.715, now it is succeeding term is equal to 5. But the previous digit, the preceding term is odd. If it is odd, I will add plus 1. If it is the previous term is odd, then I will add plus 1 and I will write 2.72. If the previous term is even, then you will simply leave off. You will drop down 5. You will get only 2.74. So, this is how we round off significant figures. They have asked 3 significant figures. So, I am rounding off to 3 significant figures. So, I have 4 terms. I will round off to 3. So, I have to consider the last term. What should I do with that? If it is greater than 5, 6, 7, 8, then my preceding term will be raised by plus 1. It is 2.75. If it is not equal, if the succeeding term, last term is not equal to 5, it is not close to 5, then I will simply drop that last succeeding term. I leave that term. It will be 2.74 only. And the last term, if it is equal to 5, then it is a complex. You should think more. If it is equal to 5, if the preceding term is even or odd, you should consider that. If it is even, then you will leave this 5 as it is. You will drop down the 5, you will only write the preceding term as it is. If the preceding term is odd, instead of even you have odd, then 5 has importance. So you will add +1 and write the answer as 2.74 if it is equal to 5. If it is greater than 5, then you simply add +1 and write the preceding term as 5. So this is about rounding off of significant figures. So next you have a numerical. You have numerical 1. Each side of the cube is measured to be, so side is given by A, 7.203 meter. It is given. A is 7.203 meter. What is the total surface area and volume of cube to appropriate significant figures? Significant, we learned what are the rules for significant figures. We learned how to round up significant figures considering 5. So keeping all that in mind, we have to solve this numerical when it comes to significant figures. So I have cube. So what is the total surface area? I will represent it as TSA. Total surface area of cube has a formula. How you find out total surface area of cube? Think about it. It is 6a square. Consider a cube. Cube has 6 faces, 6 into sides. So it is given side which is represented as A is this 7.203. So 6 into 7.203 square. So what will be my answer now? TSA, take your calculators and try solving it. The answer will be 311.2991. You have meter. So this will be meter. So it will be meter square. So how will I round off now? Round off the significant figures to write the final answer. You see, consider round off to 4 significant figures. 3.11 point. I look at this last digit. Round off to 4 significant figures. Last digit you can see it is 9. 9 is greater than 5, right? I'll add +1 to 2. So it will become 3 meter square. This is the total surface area of cube. This is the formula we use for total surface area of cube. Now, how will I find the volume? Volume is equal to, volume of cube is length into breadth into height. Length into breadth into height. They are given. The sides of the cube is measured as 7.203. So it will be 7.203 meter cube. Length, breadth, height, meter cube. So answer will be 373.7147 meter cube. If you calculate the value, you will have still many more units here into meter cube. So how will you round off this significant figure now? How will you round off? 373 point. After point consider. After 7 you have 1 here. You had 9 which is greater than 5. So you added +1 to the preceding term and wrote it as 3. Here you have 1. 1 is less than 5, right? So 1 is not close to 5. So you will leave this digit. You will drop this 1 and write 373.7 meter cube. This is how we find out significant figures, how we round up the value. When I have greater than 5, I will add +1 to the preceding term, and when it is not equal or closer to 5, I will drop down and leave that numerical value and write only the preceding term as it is. So this is how we calculate total surface area and volume of cube. So next I have numerical 2. 5.74 gram of substance occupies 1.2 centimeter cube. Express its density by keeping the significant figures in your view. So mass is given, volume is given. Occupies, it occupies a volume of 1.2 centimeter cube. So analyzing, understanding numerical and connecting formula is important. So this is gram, that means mass is given, and centimeter cube. Occupies means volume is given. How will you calculate density? Density is given by mass by volume. Remember the formula how you calculate density. M by V. What is M? 5.74 gram divided by 1.2 centimeter cube. So, how will you get density? What is the value of density now? When you divide, you will get 4.7833 gram per centimeter cube. How will you round off this? You see here, 4 point after 7, this is a preceding term and this is your succeeding term. After point, consider these two digits. After point, consider two digits. 8 is greater than 5. So, preceding term will be raised by plus 1. It is 4.8 gram centimeter per centimeter cube. Either you can write gram per centimeter cube or gram per centimeter cube. Both way are right. So, this is the value you get. So, consider I had read a rule for arithmetic operation for division or multiplication. What is that rule? Since you are dividing, consider you should keep that rule also in your mind when you get significant figures, numerical. So, for multiplication or division, your final value should consist least number of significant figures. So, mass, what is mass here? Mass is 5.74 gram. It has significant figures 1, 2, 3. What is volume? Volume 1.2 centimeter cube. So, now what is the significant figures volume has? It has two significant numbers. So, for multiplication or division, the final value, that the density has final value, the final result should consist the least number of significant figures, that the original values, that the mass and volume has. So, which has least significant figure here? Mass or volume? Volume has least significant figures. So, your final value has two significant figures, that is 4.8. I have rounded off to least significant figure. 4.8 is your density of the substance. This is how, whenever you calculate the last answer, keep the rules in your mind. You should know how you round off significant figures, and whether it is multiplication or division, or whether it is addition or subtraction. For arithmetic operations also, significant figures should follow certain rules. When it is addition or subtraction, you consider least decimal places. If it was addition or subtraction, if I had done, you should have considered least decimal place. Since it is division, multiplication or division means you should consider least significant figures. So, I have considered least significant figures. Volume has least significant figures. So, it is 4.8. 4.8 is my answer. So, in today's session, we studied what is significant figures. Now, you got to know what is significant figures. Reliable plus uncertain gives me the significant figure of the quantity I measured. So, these digits, this volume or this mass this is a 3 significant and 2 significant figures. But these are reliable and certain. The last digit is uncertain. The last digit is uncertain here. So, we do round up. We round up to 8 and write it as 4.8. So, after significant figures, we studied what are the rules. There are 7 rules for significant figures, where decimals, zeros and non-zero digit has significance in different rules. Whenever you talk about significant figures, keep all these rules in your mind for solving significant figures related numericals. After rules, we saw the rounding up of figures, how we round up the significant figures. If it is greater than 5, then the preceding term will be added with plus 1. If the succeeding term, if it is not equal to 5 or it is not close to 5, it is 1 or 2, we will drop down, we will leave that digit and write the preceding term as it is. And if it is equal to 5, then it is a problem. You should think succeeding term is equal to 5, then the preceding term, if it is even, the succeeding term will be left as it is and the preceding term will be written as it is, as 2.74 itself. If the preceding term is odd and succeeding term is equal to 5, then if it is odd, then you will add plus 1 and write it as 2.7 If it is 3 is there, you write it as 2.74. Because succeeding term is odd, you should add it with plus 1. If this is in case of it is equal to 5. Greater than 5, you need not worry. Preceding term is raised by plus 1. After that, we saw what are the rules of arithmetic operations has in significant figures. In case of multiplication or division, you consider least number of significant figures. So your answer should have least number of significant figures. If it is addition or subtraction, you should consider least decimal places. Your answer which you calculate from using addition or subtraction should have least decimal places in the answer. After that, we solved two numericals. One is based on density, mass by volume, and another one is how you calculate the side. TSA, total surface area of cube, is given by 6a square. Volume of cube is given by length into breadth into height, is nothing but the side cube. So you'll get different value and you should know how you round off the significant figures. That's all about today's sessions. So I'll be coming up with more interesting sessions on units and measurement, where we will study about dimensions and dimension quantities. Until then, see you all. Take care. Have a good day. Thank you.